everybody, Alex from Corso Systems here. Thanks for hopping on. For today's Tech Tip Tuesday, we're going to take it a little bit back to basics and talk about tags in the world of automation, what they are, why they're important, and why companies like Inductive Automation, who offer unlimited tags in their SCADA platform Ignition, are interesting and different than legacy platforms who charge you by tags for your licensing. First, we're going to dive into a piping and instrumentation diagram post from our website. We'll link to it in the description below. This gives you a basic overview of reading P&ID drawings, which are important for manufacturing processes to understand all the equipment and how everything's laid out and connected and how things operate. So you can check that out after this video. Here we'll talk about a fairly basic example you might see in industry. We'll talk about some real world examples that are not automation related, and then we'll tie it all together at the end. So here we'll see on the left we have a flow meter. This will be a device that measures flow of a liquid or gas through a pipe. On the bottom we have a sensor. This is actually what the pipe is connected to and what is sensing the flow through the device. Then on top is a transmitter. This is what is connected to our PLC into an I/O module and gives us various values we can read from that flow transmitter. On a P&ID drawing, you might see this as a flow element. And then these signals here would be tags that are going back to the PLC, a flow transmitter. So that would be our value. If there's a proportional integral derivative or PID loop tied to this valve or tied to this flow meter, maybe it's a valve or a pump that is controlling the flow through this pipe, that would be indicated by a flow indicating controller. And we may have a flow alarm low signal, maybe a high alarm, high alarm, etc. that we can use to indicate something is out of spec with the process and trigger the operators to do something with the process. These are all signals that go back to the PLC. And in this case, we would have a tag for our flow value, a tag for our alarm, and we may have a handful of tags for the controller, including a set point, a process variable, a control variable that we're sending to a valve or a pump, and maybe some other things like the proportional, integral, and derivative gain for that control, and any alarm conditions if it's in auto or manual, etc. So you may have, just to read flow, you probably have at least one tag, if not a few, to include alarms. And then if you get into control, you would have additional tags for this flow sensor, and then whatever tags are required for your equipment that's controlling flow. So in that case, the simplest explanation for what a tag is it's a data point, either coming from the field, coming from some internal logic in your PLC. It could be coming from recipes or other business systems that you're using to run your facility, depending on how you have your system set up. So let's talk about a few real-world examples. At the high level, if you're looking at our unified namespace book, this would be an example of all the types of signals that you could pull into a system. This is fairly complicated for this video. Realistically, based on what we just showed, we're going to be looking at devices in the field connected to a PLC, connected to our SCADA system, in this case, Ignition, to basically talk about tags. We'll save alarms and things you can do with tags like historical data collection and whatnot for future videos. But for this video, we're basically looking just at this piece of this puzzle to look at devices like that flow transmitter connected to a PLC, connected to the SCADA system. So a fairly straightforward real world example you might be familiar with from your house would be a thermostat. This gives you an inside temperature reading. Maybe it gives you an outside temperature reading depending on the thermostat, the time of day, if it's in heat mode, if it's in cooling mode, or if it's off. And from an industrial perspective, looking at tags, each one of these values would be a tag. So the mode that we're operating in, our current set point, what our current temperature that we're trying to control is, what our outside temperature is, and even the time could be a tag. So if we were to come over here to the Ignition tag browser in the bottom left, each one of those values here is shown as a tag in Ignition. So these could be mapped to the PLC device to read from a certain input or output for a control variable. Maybe we're looking at internal logic or timers or things. But each one of these is a tag as indicated by the icon here. So we have our inside temperature, what mode we're operating in, our outside temperature, our temperature set point, and the current time. Those are all tags. So if we're looking at this single thermostat, we have a handful of tags here. If we're looking at an industrial process, we may have thousands, tens of thousands, maybe millions of tags, depending on the process. If you're looking at a legacy SCADA platform that charges you per per tag. Let's say you buy a 5,000 tag license, you can pull across 5,000 data points from your PLC within that license. If you want to have 5,001 tags, you need to increase the license. Maybe it's a jump from 5,000 to 10,000. So you're going to at least double your cost, even if you're not going to utilize all of those tags. The power of ignition, having unlimited tags, is within the operating parameters of our PC or server hardware, meaning we may reach a point with 1 or 2 or 3 million tags where we need to split up our ignition gateways into multiple machines. Well outside the scope of this video, but on a single gateway, we can have as many tags as we want to have coming from our PLCs. This means we're not limited to any amount of data that we can pull in from the PLC, and allows you to be a lot more granular with what data you're looking at in your PLC to begin with. Now, for a more advanced real world example, if we're looking at the dashboard of a car, this gives us a lot of different data points shown here. Say our speedometer, our fuel tank level, if we have a check engine or a low oil light on, our outside temperature, our odometer, maybe a calculation for our average miles per gallon that we've driven since we've reset that, a range based on our fuel level, if we're in park or reverse or drive, maybe our engine RPMs and the engine temperature. Those would all be tags. In this case, coming from the computer running the brains of the car. In the industrial world, this would be coming from a PLC with field devices connected to it. So if we show all of our tags here, we have a bunch of different tags coming from the car dashboard alone. And if we pull up our car, we see all of those tags configured in ignition. And again, these could be mapped to a PLC, pulling across information on pump and motor speed, valve positions, flow rates, temperatures, anything that you're measuring or controlling in your process. We'll also see here that we have different tag types. So the check engine light is a Boolean tag, so that means it's either on or off. That might be mapped to something called discrete I/O in the PLC world, which is a discrete value of 0 or 1, meaning the sensor is on or off. That's useful for things like level switches in a tank. If you're measuring the high level, you'll have a sensor in there that goes on when you've reached a high level and goes off when you're below it. The odometer would be akin to a totalizer. So if we're looking at the flow meter example from before, maybe we're looking for the total flow per shift through that pipe. So that would be something we're running a calculation on to sum up the flow over time. We'll also see we have integer values like for our range and our engine temperature, where we don't need the decimal points. Our fuel level and our miles per gallon are floating point values or real values that give us 0.1, 27.5. So we have a little more granularity. And then based on the data type, since we're looking at a character P for park on our shifter, that would be a string data type. And you can have multiple different data types or even complex data types like arrays or JSON data if you're looking at more detailed information on a per tag basis. So that gives you all the tags coming from a car. Again, if you have one car in your system, you have 10 or 12 tags coming from that. If you have 500 cars in your fleet, then you have 500 times as many tags, and that's where you get into the power of Ignition's unlimited tag licensing model. Going back to our thermostat example, this is fairly similar to a heat treatment operation where we're going to be controlling the temperature in a furnace based on a set point, and we're going to be monitoring that and controlling, in this case, the thermostat would control the signal to the furnace in your attic or your air conditioning unit to heat or cool your house. We're going to be controlling burners or electric heaters in a furnace to control the heat in that furnace to meet the desired design requirements for whatever parts we're heat treating. If we look at an industrial example here, this is a heat treating furnace. Parts move through the furnace here on the top on this drawing. There's 3 different heating zones and a soak zone, and then a cooling zone at the end that we're controlling with sensors that are reading the temperature from a thermostat. The operator is giving it a set point, and the PLC is controlling the operation of the furnace to meet the set point. We also have some Boolean values indicating if a safety relay is on or off, meaning the furnace is okay for safe operation. And in this case, if the burners are on or off, and then we would be sending a certain percentage of gas to the burners to maintain our temperature. And then on the cooling side, we would give it a set point where we're trying to cool the parts to, it's blowing a fan with ambient air onto the parts. And we have an actual temperature and say what our valve position is for the blower. That controls how much airflow is going through that. You could also control blower speed or other things. And then down to all the conveyors. There's conveyors that are rolling the pallets of parts through the furnace and then through this staging area where they can load and unload the parts from the system, loading parts onto the pallets or the pallets onto the conveyors as they need to be heat treated, and then they would go through the process and then pulling them off and taking them for further processing once they've been heat treated. We'll also see here, each one of these red squares is a position on the conveyance system. So there's a photo eye, which is basically a sensor that detects if something is in the way of the photo eye to indicate if there is a pallet in that position, indicated by green, or if there is no pallet in that position, indicated by red. And then between the positions here on the bottom, we see different motor graphics. Those would be motors similar to the engine in a car that we can control whether they're on or off with a start or stop signal, similar to the ignition in a car. We can control the speed of those. If we want them to go at a particular speed, we may not have something called a variable frequency drive, and the motor would just run at whatever speed it's wired to. Or like the engine in your car, you can have a variable frequency drive that controls the speed of the motor, allowing you to speed it up or slow it down. In this example, we could make the conveyors go faster if we wanted to, or if you're pumping liquid through a pipe, you could speed up the pump using the VFD to push more liquid through the pipe, or slow it down to push less liquid through the pipe as needed. So that takes you through some real world examples, up from the very basics of how a sensor is connected to a PLC to give you a reading, up to the thermostat and the car examples for some real world data points coming from examples you might be familiar with, all the way up to the industrial world, where we're looking at an example of a real world system with actual sensor readings coming from the field, set points that the operator sets in the SCADA system, and the PLC would manage controlling all of that from there. I hope this was a helpful dive into what tags are in the automation world and why they may not be important. And hopefully that helps you understand the power of ignition with its unlimited tag licensing model. And again, we'll dive into more advanced things you can do with tags, like collect tag history, deal with recipe management and alarms, and various other sorts of things in future videos. Thanks for watching. Have a great day.